Hello everyone. Today we are going to study about the topic regarding to the TOC, theory of computation. The main concern in the TOC is we have to understand basically the what is grammar, what is language, and what is the automata. First of all, we have to difference the meaning of grammar, automata, and then grammar, and then we can jump to the topic. Okay, let's discuss about mainly three topics. There, grammar, language, and automata. In theory of computation, we have one machine which accepts certain language like finite language, regular language, and then deterministic and non-deterministic, context-free language, and so on. And for the generation of that language we use certain types of grammar. They are considered as from the topics of Chomsky. We have different types of grammars. They are like type 0 grammars, that is unrestricted grammars, and there is a type 1 grammars and type 2 and type 3. Okay, first of all we will discuss about the automata. Okay, what are the machines that are present in the TOC which accept certain language? Okay, let's discuss about the automata. We have different automata. There is one finite automata. Yeah, there is a finite automata which accept regular language. Yeah, and then that regular language is generated using the regular expression. Okay, and then we have one machine that is push down automata. Mainly there is a deterministic push down automata which accept the language that is context free language, and that context free language is generated using the grammar that is context free grammar. Yeah, and then we go up and then we have the non-deterministic push down automata which accept both the infinite and finite types of language set, that is push down automata, and that push down automata accept the language that is context free language. But here if you observe here, there is a automata that is deterministic push down automata which only accept the language which is deterministic, means which does not contain any types of guesses and then any types of like suggestions, guesses. Yeah, so that deterministic push and automata always accept the deterministic context free language. After that we have the push and automata which accept finite and infinite context free language that is generated using the same context free grammar. And there is a whole topic, this is a whole topic we will discuss later. And then after finite automata there come the push and automata, and about the in the advanced form of the push and automata there is a more increment. Yeah, according to the time, in the period of time machine get developed, so that initially there is a finite automata which only accept the regular expression, and then there can be some types of infinite and non-regular expression, and that cannot be determined using the finite automata. For that, in order to determine that infinite or unregular expression, we develop one machine that is push and automata which comes with the one stack. Like if we have initially we have the finite automata, yeah, which only accept the regular expression. If we have to compare the language, like let's say there is a A1 and B1 is our language. Yeah, and if we have to compute this on the computer, then we have to compare, because after coming to A we have to come to B. Yeah, if there is a 2A and then there must be the 2B, there is a comparison in machine, in memory, so that the push down automata can do the comparison, but this finite automata can't compare these types of language. So that finite automata with one stack provide push down automata. This is also memory, yeah. This is a limited memory, and in that limited memory, if we add one stack, and that can help to compare this language, so that this types of expression which is done by the machine, which is considered as a push down automata. Okay, let's jump on our continue. After push down automata, we have one more automata, that is limited boundary automata. These types of machine mainly accept the context sensitive language, and this context sensitive language is generated using the grammar, that is context sensitive grammar. This is more advanced type, and this is the type this is the type 1 types of grammar. And then after this limited boundary automata, we have the tuning machine. Yeah, we have the tuning machine, but there is the two types of tuning machine. One is holding tuning machine, which get held after some expression, that is holding tuning machine. This holding tuning machine accept the language, that is recursive enormous language, and this recursive enormous language get generated using the language this language regular enormous language is generated using the grammar, that is like say unrestricted grammar. There is one unrestricted grammar. Using this unrestricted grammar, we generate the language, that is recursive enormous language, and which get accepted by the holding tuning machine. After that, we have the main tuning machine, which accept the same recursive language, and that get generated using the same non-restricted grammar. And after that we have the language that is about 2 to power epsilon asterisk, which is above. These types of language are not accepted by any types of machine, because this is the advanced and this is the futuristic types of language, which in the future there can become some machines which can accept these types of language. This is the advanced and this is the more complex types of language. Such machine has not exist at present, so our world is only focused on the tuning machine only. Okay, and let's say this is the type 0 grammar according to the Chomsky, and then this is the type 1, and this is the type 2, and this is the type 3 grammar. Okay, we already discussed about the automatas, what are the different types of automata that are present in the TOC, and that automata is a machine. Yeah, this is a machine, and that machine have to accept some types of language in order to process some types of operation, so that these are the language and these are the expressions which are accepted by the particular machines. And there is a language, but how this language is generated, that is still only with the grammar. If there is no any grammar, then how can you generate the language? Like let's say the one example, without knowing the past tense, future tense and present tense, how can you make some statement regarding some condition? We can't. First of all, we have to know the grammars. Grammars provide you the some rules and regulations, some types of restriction which are used fully on the language or statement in order to generate some types of meaningful statement. Yeah, so in order to generate the meaningful language, we have to use some types of grammars according to the needed. Okay, now let's say we have the finite automata. If we add the one stack in the limited memory of the finite automata, that provide us push down automata, because after this push down automata, the machine can compare two strings. Yeah, if we add one stack with this push and automata, then that can bring us to the tuning machine, and tuning machine will be achieved. And tuning machine can have the ability to compare more than two strings. Like let's say example, there is a an, bn and cn. These types of string can easily compared and calculated or operated by this tuning machine. Okay, this is the basic knowledge regarding to the TOC, which must be known before studying and going deep to the syllabus. Okay, thank you.